Hello and welcome to Textbook Engineering Problem. Today we're working out of Elementary Principles of Chemical Processes, 3rd edition, and we're doing problem number 7.2. We'll continue our trend here on chapter number 7 problems. I've gotten a request to do all of chapter 7. I don't know if I'll be able to do all of it, but I can do quite a bit of it and hopefully explain some of the background information so that you can understand kind of some of the meat of these problems a little bit better, help you conceptualize how to work through them and what they're after and why certain concepts are important. Okay, so today we're doing problem number 7.2, like I said, and I'll go ahead and read the problem. Consider an automobile with a mass of 5,500 pounds mass braking to a stop from a speed of 55 miles per hour. Part A, how much energy in BTU is dissipated as heat by the friction of the braking process? Okay, so we've got right there our pounds mass, and we've got a velocity. Okay, so then friction heat, if all of the kinetic energy of the car moving, the car comes to a stop, there's air friction, then there's friction on the ground, the tire on the ground, and then there's friction with like the actual brake pad and clamping that. Okay, so that's all that friction heat, right? All that friction heat. Well, that friction heat equals the amount of energy that was in the car to begin with, which would be its kinetic energy. Okay. Okay, so kinetic energy is 1/2 m, the mass, times the velocity. And now I'm just realizing I may have forgotten to calculate the 1/2. So let me just check that real quick. But this is how you would set up the problem. It's just a energy or a units change, right? So we calculate the units and we get megajoules. I know I set this up correctly, but this number might not be correct. So just make sure that I put the number in correctly. Okay, or when you do it in your calculator, make sure it's correct. Remember, these are squared, right? We've got squared values here because the distance and time here are both squared. Okay, so the unit conversions have to be squared. That's the tricky part. The part that I might have forgotten to do was the divide by 2 to begin with. Okay. So my numbers might be wrong here, but you guys can calculate that because it is set up correctly and the unit conversions are correct. Okay. Okay, so first I put everything into joules, right? And then it's easier to go from joules to BTU. So that's what I did afterward. Okay, so I got BTU. Like I said, this number might not be correct, but those units are correct and the unit conversions are correct. Okay. Part B. Suppose that throughout the United States, 300 million such braking processes occur in the course of a given day. Calculate the average rate in megawatts at which energy is being dissipated by the resulting friction. Okay, so we've got 300 million brakes per day. Okay, brakes per day. If we have 1.5 megajoules per braking process, right? Then we just need to convert these days into seconds because joules goes into watts. When you have joules per second, it turns into watts, okay? Our brakes here cancel out, okay? And then days cancel out, hours cancel out, okay? So those unit conversions are correct. Again, this number might not be correct because we used this same number that we calculated up here, and I think I forgot to do the 1/2 there, okay? But you understand the process. It's just unit conversions, and you have to be able to tie things correctly into your calculator, which I sometimes struggle with if I'm using like the calculator on my phone or something like that, which I did in this case. So bear with me. Sorry about that, guys. Anyway, that's how you would do that problem. I think they're just trying to get you to think about magnitudes of energies here, right? So like, hey, here's a car. This is how much a car generally weighs. Miles per hour, 55 miles per hour is like an average like speed for cars because you have some moving faster on the freeway, some moving slower through town, things like that. So 55, okay. If they're all braking to a stop, 300 million times a day, then that's a lot of energy going to waste, right? And that was kind of the concept or the idea of why people started building hybrid vehicles. Okay, so the hybrid vehicle said, hey, there's a lot of energy that we're just turning into heat and not using, right? So why don't we just try and capture that energy? So instead of using like a friction brake that turns all the energy into heat, why don't we put a coil on the brakes and use the inductive process? So then you get inductive brakes, right? And then you're generating an electrical current instead of just heat, right? And so then you can use that electrical current to charge a battery or something along those lines, right? Okay, so then some of this energy, a fraction of this energy, instead of just getting turned into heat and then just leaving our planet at some point, it turns into useful energy that the car can use again. Okay, so that was the idea behind hybrid cars. All right. Well, that is it for problem number 7.2. Thanks for watching. Please remember to subscribe and to like the video, leave any comments. Maybe one of you guys can leave a comment on the correct numbers or if I calculated that correctly, so that other people can check the answer, and then I'll pin your comment so other people can check that answer once it's done correctly. Anyway, thank you. Hope you have a good day. Bye.